Okay. We will do now the dynamic programming example. Dynamic programming, in that we studied particularly the backpack knapsack problem. So what we said is I have 4 items. Item 1, weight is 2, value is 10. Item 2, weight is 3, value is 7. Item 3, weight is 4, value is 15. Item 4, weight is 5, value is 8. Right? Yeah, weight is 5, value is 8. So we want to take as many as these 4 items as we can, but we have a weight restriction that our weight has to be less than or equal to 5, let's say. Okay. And we want to maximize the value, right? So how we do it? We do it in a step-by-step process, and we try to um, fit a sub problem, solve a small problem. And when we are solving a bigger problem that includes this small problem, we will not recompute, we will look up the table. So we will create that table. The table is called memoization, right? So our weight capacity is 5. So 0, 1, 2, 3, 4, 5. And let us say we started with our item 1 and whose weight is 2 and value is 10. Weight is 2, value is 10. Right. When the weight is 2, if my knapsack can only allow 0, I can't take it. By the way, I could have started with any product. I just started with the first one. Okay. If it allows only 2, if my first product itself is 2, if it allows only 1, I cannot again take. My knapsack has to be empty. If it allows 2, my product weighs 2, I can take that. And if this is all I have, I'll get a value of 10. Even if it allows 3, if all I have is this, I can only take that item. So my value is 10, my value is 10, my value is 10. So if all I had is item 1, if my knapsack allowed 0 kgs, 1 kg, I wouldn't have taken anything. 2, 3, 4, 5, I would have just taken that item. Now, if I add item 2, and this has a weight of 3 and value of 7. Now, what I do is I will see if I include this, what is the best I can do. If I don't include this, what is the best? So I now have 2 items, item 1, item 2. There are 2 ways in which I can go. One is I can include item 2 and see what is the value. 2 is I don't include item 2 and what is the value. Again, if I have item 2 included, it is 3 kgs. If all is allowed is 0, so I can't take it. If I don't include it, this is the size, so I can't take it either way. So here, Again, if all allowed is 1, if I include it, I can't take it. If I don't include it, the best is 0. So if I'm allowed 2 cages, if I include it, no, I can't take it. If I don't include it, yeah, this is the best. 3, I can include it. If I include, I'll get a value of 7. If I don't include it, okay, the best that can happen is 10. Now, if 4 is allowed, again, if I include it, um, I will get a value of 7 and 1 kg is left. Okay, because 4, I included 3, only 1 kg is left. For 1, the best I can do is 0. So if I include it, I will put that, I get a value of 7. 1 more kg is there. I'll see the best case scenario for 1 kg, it is 0. So I can't do anything. If I don't include it, this is the answer, so 10. Now, if 5 kgs are allowed, I include 3. Okay, I get a value of 7. And now 2 more kgs are left. The best I can do with 2 is this 10. So this 7 and this 10, 17. Right? So that is the best case scenario. Now let me include the third item whose weight is 4, value is 15. Now again, there is not much that I can do if all I am allowed is 0. All I am allowed is 1. Whether I include, I can't include. If I don't include, the best is 0. In 2, I can't include this, otherwise the best is this. In 3, I can't include this, the best is this. If with 4 kgs are allowed, I can include it. I get a value of 15 and then nothing else is left. So the 15 is the best value. If 5 kgs are allowed, if I include 4, I'll get 15 and then 1 more kg is left. The best I can do is 0. So 15. On the other hand, if I don't include 4, the best I can do is 17. Okay. Now, item 4, the value weight is 5, value is 8. So if I can't include here, so the best is without it. I can't include this here, so the best is here, 0. I can't include here, the best is 10. I can't include here, the best is 10. I can't include here, the best is 15. Now at 5, I can include it. I get a weight of value of 8 and nothing else is left. So 8. If I don't include it, this. So this is my all kind of possibility. See, I haven't computed to look at without including what is the best. I just looked up. I didn't recompute. Just said, hey, you know what? Anywhere I can, if I 4, I either include it. If I don't include it, I just looked at it up. If I here I included 4. Okay, for 4, I add 15 and then for 1, 0. I just am looking up. Okay, so now this is very good, but this is because of this combination. This is because of this combination. So this is the best combination that allows for the weight restriction of 5 and value of 17. So I will include item 1 and 2. Together they weigh 5 kgs and they give a value of 17. So once I compute the memoization table, this is the highest value this is going to be, but I will check for where it originated, because this, if it was if this was 17, all others are something else lower than that, then this combination would have been the best. But here, this is not originated from here. This came because I didn't include this. This came because I didn't include this also. I included this. Okay, so this is how memoization dynamic programming problems are done.